Hello friends, welcome back, and in this lecture we are going to discuss about the interface segregation principle and its implementation. That we need to understand that in which situation we need to break our code to follow it to interface segregation principle, and what are the situations which leads to the problem with the code which violates the interface segregation principle. So for that, I mean, this is very simple to understand, and we have already understood in the theoretical part of this particular playlist for the interface segregation principle. But in this particular video, I am just going to show you the things which are related to the code only, and we can understand that with respect to the code example. Okay, so we have to understand here there is one class. This is C++ language. I have written all this code in the C++ language, and in case of C++, there is no such word like interface. In case of COM, you can see the interface keyword and the use of the interfaces, but and in normal C++ code you will not be able to see that interface keyword, just like the class and the namespaces. So here you can see the the class and the namespaces only. There is no such word like interface here. There is no such keyword. So how to create an interface like situation? In case of C# language, in case of Java programming language, you can see the interface keyword is there, but in case of C++ language, there is no such keyword like interfaces. So how we simulate the situation of interface with the C++ language? So in case of C++ language, what we do, we create a class which is abstract class. Abstract class means the implementation of all the functions, any function in for this class is not necessarily needed in this class, and the instance of this class cannot be created. This class cannot be instantiated basically. So what we do, we create a class which cannot be instantiated. So for that, what you need to do, if you have to create a class which cannot be instantiated, you need to write something like this: virtual void function name is equal to 0. Once you write like this becomes a pure virtual function, and anything where there is a pure virtual function, you cannot inherit this class. You cannot instantiate this class, right? You can inherit, but you cannot instantiate this class. Now in this class, I can see there are three functions. One is work, one is calculate salary, one is calculate bonus, and the name of this class, which is acting like an interface, is worker. So basically I'm creating an interface for the workers, and using this worker interface, we can implement the behavior for the different worker classes. We can create number of different classes where we can give the implementations. But suppose I'm going to create a class which is a real worker. Real worker means like me, like you, the humans, right? Real worker. And I'm just going to do like public worker. I'm going to inherit this thing, okay? Okay, so if I'm inheriting this, then what I need to do, you can understand, if you have understood this, if you know this concept in C++ programming language, if there are any virtual functions inside this worker class, these are all the classes, the pure virtual functions. You must need to implement them in your derived class, right? So if I'm writing like a real worker class, where I'm going to instantiate those workers which are like me and you, which are the living human beings. Then to implement the behavior, I have to implement all these methods, right? I need to do something like Control C, and then I need to give the implementation here, right? I need to give the implementation of each and every function which has been mentioned there in the superclass, right? All I need to do, right? And now I'm just going to write another class robo worker. I'm writing this class robo worker, and I'm publicly inheriting this worker class. And since I'm inheriting this worker class, and this class again has these three pure virtual methods, so what I need to do, I need to again implement all these methods for the robo worker as well, right? So for the robo worker as well, I need to do something like this: public, and then I need to write like virtual void work, these methods, Control C and Control V. I need to do all these things. I mean, I need to implement all these methods. If I does not do this thing, and I just leave the implementation of these two methods like calculate salary. I don't need to give the salary to the robo worker. Robot is not something who will be asking for the salary, right? So if I compile it, then the build has been succeeded. The thing is that when I will start using it, right, if I will start using it, then in that case, if I don't have implemented these things, then the problems will come, right? But again, whether the compilation problem comes or not, do you think that this particular method, calculate salary and calculate bonus, should I be forced to implement here? I should not be forced to implement here. If you will see this thing in the other other programming languages like in C sharp, then in that case it will not even compile. This particular code even not will compile, right? In C++, until you use it, until you call this function, until you create a create an object like robo worker. I'm creating it R. So if I create it, and now if I try to compile it, let's see what happens. Right, so here you can see a robo worker cannot instantiate abstract class until it implements all the methods. Like if I implement all these two things, right? So if I will be using robo worker in my code, then in that case you will be able to see the real problem. So if you will see this real problem, now it will be succeeded. Until I implement all these functions which are not necessary for a robo worker, this code is not going to be compiled, right? So do you understand? I need to implement those two functions which are not necessarily useful for me. I don't want to implement them, right? But still the interface was written in such a way that I must need to implement these methods. So such kind of interfaces are known as the polluted interfaces or the fat interfaces. These fat interfaces are written in such a manner, when someone decided to put all these things in a class, that low level designer or the architect didn't take care of this thing, that this is violating the principle of interface segregation, right? And this is basically polluting the interface, and every method of this particular class must need to be implemented. So that is what is happening, and this is not a good thing, right? If you remove any of these methods and if you now compile this, so you will be able to see robo worker cannot instantiate it, because until you implement all the methods, it will remain abstract class, right? So if you have to implement the robo worker, you have to implement every function. If you have to use the robo worker class, you have to implement every function. So this is not good. You should not be forced, the client should not be forced to implement a method which is not useful for this particular class, for the client class. So this is what the interface segregation principle says, right? Now what we can do to make it good, so we can create a worker, right? And then these two methods I can just put in the other class non-real worker. I can create two interfaces, so I can segregate the interface into two. So here I am writing these two, so I am writing like public. Now you can see there is worker interface which contains the work, and there is a non-real worker. Sorry, in the worker you can put like, okay, in the non-real worker you can put this thing, all these things, and work can be placed here, right? Here you can put it. Or you can do one more thing, you can create a top level interface. You can create a top level interface where class worker, you can create a class top level interface, and you can create a worker real worker, and here inside the top level interface you can do something like this public, and then you can give the common feature which is the work. So you can give the work here, and for the non-real worker, when you for the real worker the salary will be calculated. For the the work is the important thing. So on the top level interface you can put this work method, but for the real worker you will have this calculate salary, calculate bonus, and for the non-real worker you can have like virtual void calculate maintenance cost, right? So this is 0, again it's 0, right? So here non-real worker has been this real worker, this non-real worker, this is inheriting it from the public worker class, and this is the top level interface, right? And now if I do this non-real worker, then also this need to be inherited from the non-real, the worker interface, right? So public worker. So these are the two interfaces which I have inherited from this base interface, which is known as the worker. Now, what will happen? I have to create a class, right? I have to create a class, real worker, right? So if I have to create a real worker, then in that case, I can inherit it from the real worker. Here is the real worker. Here, you can give it a name, give it a different name, human worker, and then you can give like real worker. So if you do this real worker, then you need to implement these three methods. This virtual void work, this you need to implement, and you need to implement the other two methods which are there in the inherited class. These two methods, right? I hope you are getting this point, because this is not a programming language class. I hope that you know about these implementations and these virtual methods, these pure virtual methods, and why you need to implement them. So I have created a worker class base interface, and then I have created the real worker interface, which is inheriting from the worker interface. And if you are creating a human worker, then in that case you need to inherit from the real worker, right? And now all these methods you need to implement, right? And if you are creating robo worker, then you need to create non-real worker. You need to inherit you need to implement the non-real worker. You need to inherit from the non-real worker, and you need to implement the work and this method, non-real workers method, calculate maintenance cost, right? So this way, if you see, like in the robo worker, you don't have to implement those methods which are not necessarily useful for you. Basically, we have segregated the interface so that unnecessary method doesn't need to be implemented by the client class, right? So now if you use any of the classes, build any of this solution, then you will not be able to see any problem. If you create robo worker, you have created robo worker, and now if you create the human worker, right, in human worker as well, if you see SW, then in this case, what you can do, in this case as well, you can do the human worker. This is succeeded. So you can use any of the methods for the human worker. That will not be any problem. You can call these methods and there will not be any issue. See, everything successful, build succeeded. So this is how you can rearrange your code. You can refactor your code to segregate the interfaces in case any of the interface is polluted in such a manner that it forces the client to implement those methods which are not useful for it, right? So these kind of interfaces are known as the polluted interfaces, and using this method, like using this principle and how to deal with this kind of situation, you can get rid of this particular problem, and your code will be maintainable later on, right? Unnecessary piece of code, why to have the redundant piece of code, right? So all these things need to be removed like this in case any polluted interfaces are encountered, right? So with this, I would like to say have a nice day and bye bye. I hope you might have understood this, and I will give this piece of code in the comment section. I will try to give this piece of code in the comment section, and you can copy and paste it from there. With this, I would like to say have a nice day and bye bye. Thank you.